All right, so hopefully you've looked ahead at this problem and maybe gave it a try on your own. But let's go through it. So we're told that the total annual global carbon emissions grew from 534 million metric tons in 1900 to 4,053 million metric tons in 1970. Assuming that the growth is exponential, we are asked to find the annual growth rate over this period. And we're told to just let the year 1900 be t equals 0. Okay, so we want to find a formula in the form q equals ab to the t. Okay, I'm going to assume that anyway. You could probably do it the other way too. Try and find a formula in terms of e, right? You should get the same answer. What we want is the annual growth rate over this period. So we want r, which means that with this form of the equation, you are getting, this is going to be 1 plus r to the t, right? Because b is equal to 1 plus r. All right, so let's figure out, okay, at t equals 70, which is 70 years after 1900, we have, so initially we're told that we have an initial output of emissions of 534 million metric tons. So that's going to be our Q0. So we have, which is A, 534. A is 534. And we don't know B. That's kind of what we want to find. If we find B, then we can find the growth rate, right? So we can find the annual growth rate. So, but we know that when T is equal to 70, that's equal to 4,053 million metric tons. Okay, so our units are in million metric tons. So we better keep track of that. Our T is in years. Okay, so now I can just divide both sides by 534. So I get B to the 70 is equal to, when I divide that, I got 7.58989. Okay, now I can just take both sides to the 1 over 70th, right? So I can just do this, 1 over 70. I put it, and then I can put it in my calculator. So B is equal to 1.0294. Okay, so there's our B. We want to find the annual growth rate. So we know that, well, we have the initial amount. A was equal to 534 million metric tons. Okay, well, now that's not what they asked for. We want the annual growth rate. Okay, so we know that this is equal to 1 plus r. So then r has to be equal to, r is equal to 0.0294. Now we could also write that as a percentage. So that would be 2.94% per year. Okay. All right, so that's the annual growth rate. Now the second part is asking for the continuous growth rate, which now we just need to convert that formula that we just found, or well, we don't really have the formula yet. We have the B. Let's go ahead and write the formula, because Q would be equal to 534, and then our B value is 1.0294 to the T. Okay, so that's our formula in that A, B to the T form. We can find the continuous growth rate if we convert that to a e to the kt form. All right, so we can say Q is equal to 534, and to convert this, we're going to do e to the natural log of 1.0294, okay, because that is 1.0294, which we found from above. and then to the t. Okay, and then we can calculate the natural log of 1.0294, and we get e to the 0.02895 t. Okay, so now we have it in e to the kt form, and so that's telling us that k is equal to 0.02895, okay, which is about 2.9%, 2.90% per year if we were rounded off to 3 significant figures. All right, so per year. All right, so that takes care of example 5. We're going to talk about a couple more things before you do your discussion questions. We're going to talk about doubling time, and we're going to talk about half-life.